Hello everyone. We are going to start class today with just reviewing that app task. I want everyone to be prepared for when they get the revision. So we're just going to take a look at the same example we looked at last class. Sorry if it's a little bit boring. So if you remember, we had the football and we knew that we could model this with a quadratic. The first step was to put it on a grid so we could get a picture of what it looked like. And then we knew that we needed to find the vertex, so that highest point, and then the release point, because that was what we were given, right? We can measure that distance of how high his foot is. When we pull up those 2 points, we have some messy decimals, but that's okay. Still numbers, we can work with those. The vertex gives us h and k, so that's important. The h is the x, the k is the y. The release point gives us an additional point, x and y, that we can plug in. When we strip it of the context, we just have a quadratic that we can solve. So we plug in x and y from the vertex, and then we take our additional point down here at the release, 0,6.122, and we plug that in for x, plug that in for y, and then we can solve for a. So that was the process we went through. We looked at a bunch of student examples last time, and when you get your app task back, keep this problem in mind. Keep in mind that it's just a quadratic. What we need is the vertex, and we need one additional point. So see if you can look back at that problem and give it another attempt. Decided to push this transformation test back a day. People made a lot of progress, I think, last time on the stations activity, got a lot of good practice in, and I think another day of practice is what we really need so that everyone feels really confident when they take the test. So real quick, I just want to go over a couple problems from the homework. Have your comp book open because I'll have you try a problem or two in a moment. So make sure you have a pencil and a composition book. If you don't have that, get that out now, please. All right, let's look at each function here. We know that we have to identify an equation, and we also have to write the domain and range, right, in interval notation. So first, I need to make sure I have 2 of my key points. I'm going to zoom in on this graph here. My locator point is down here, and that is -4, -5. That gives me 2 values. It gives me my h, and it gives me my k. Now we need to find one other additional point, and I'm going to use this point because it looks easy, and that is 0,1. And my additional point gives me an x I can plug in and a y I can plug in. Now I need to make sure I have my graphing form ready to go here. This is my square root. And now I can start plugging this stuff in. So y, I'm going to put in 1, because that's my y value up here, equals a square root x minus -4 minus 5. And, sorry, this should be 0, right? I put in x, but I'm actually trying to replace x with 0 so that I can solve. Now my only variable is a, and I can solve for that, right? So I add 5 to both sides. It gives me 6 equals a square root of minus a negative, it's positive 4. 6 equals a square root of 4 is 2. Divide both sides by 2, and I'm left with a equals 3. I'm not done yet because I still haven't written the equation, right? So my final equation, y equals 3x. My h is positive 4 because it's minus a negative. Sorry, this should be square root. Minus 5, right? Because it's down 5. So that is my equation. My domain is the collection of all the x values. My smallest x value is over here at -4. And -4 is part of the domain. So I use those square brackets. It goes on forever. So my upper range is infinity. My range, well, the smallest range here, the smallest y value we have is -5. -5 is included, so I use square brackets, and it keeps going up forever, so I use infinity. Okay, I know you all have your comp book out and your pencil ready because I asked you at the beginning of the video. At this part, I'm going to ask you to practice solving for a. So you have this equation or this graph down here. We have some important points that are labeled. So you need to think about how you would find the equation for this. You have to solve for a. Write it out, pause the video, take a second to do the math, and then we'll check our work in one moment. All right, this should look like your equation. We have a value of -2, it's pointing downwards and it's steep. Down over 1, down 2. You can look at the slope triangle there. We have it's moved in the right 2, so that's the h should be -2, and then it's shifted down 1, right? Domain, well, every x value is part of this function, so the x's go on in the negative direction forever and in the positive direction forever. For the range, the lower boundary is -infinity, goes down forever, but the upper boundary is -1. -1 is the largest y value in this function. With the second type of problem, you are given the equation and you have to draw the graph. So if you are really comfortable with your parent functions, challenge yourself to do this without a calculator by looking for the vertex and then thinking about the steepness of the graph. If you want to check your work with a calculator or that helps you get started, by all means, use the tool to help you get started on this. So our vertex, we have no h value, but we do have a k, so it's shifted down 6, 0. It's a cubic. Normally our cubics, we go over 1, up 1, right? Now it's negative, so we go over and down. And instead of going down 1, we go down 0.5 of 1. So our value would be there. Because of the symmetry, I know when I go left 1, I will go up 1/2 as well. Over 2. And now instead of going up 8, I'll go up 4. 1, 2, 3, 4. Since 4 is half of 8. Over 3. And you can complete the rest of the sketch yourself. Keep in mind that the locator point is right here where the graph swerves, and that would be 0 and -6. And my sketch isn't super great here because it didn't go through that point. And that looks a little bit better. So try to make your sketches as accurately as you can by at least plotting 2 or 3 or even better 4 or 5 points, and then connecting the points to create a smooth line. So that's the end of our practice today. Do your very best on this practice test. Grade it, take it home, look at it over the weekend, come back with all your questions. We'll spend a little bit of time reviewing. I can answer any of those questions, and then we'll take the real learning target test. I hope you all have a wonderful long weekend, and I might see you tomorrow if you have any questions before those quarter grades come out. All right, enjoy class.